This is Ask Brock. I'm Brock Yordy. This week's question comes from Dillion. Brock, the engineers on the large project I'm about to start asked for a fluid disposal plan. We've never built one before. Any advice? My first advice is work with this engineering firm and GC as much as possible, because 8 times out of 10, you're going to be responsible for those cuttings, though they're their cuttings. You are a co-generator. And depending on where you are, what state, what regulations, and is this an urban project for geothermal? Is this a project that has some forever chemicals in it? Or is it just going to be a ton of development spoils that is beyond that 10 NTU release level? This is great that they've asked, because this should not be on us. A few weeks ago, my wife wanted to get an estimate on getting our kitchen redone. There was $25,000 in there for lead and asbestos. They just didn't need it. What are we doing as an industry thinking about that? So it comes back down to our basic solids control and our expectations, but our X factor is how much time it's going to take for development in a water well scenario, or how much displacement we're going to have with grout or water we produce on a geothermal project. So I want you to take that borehole, times it by 3 for total hole volume. I want you to start looking at the cubic feet of material that you're going to remove out of that hole. I want you to think about the amount of fluid. How are we separating that? Do you have a solids control unit? Are you using a filter press? Do you have centrifuges? Is Badger just going to show up with a vac truck and take it away and dispose of it that way? Do we have roll-off tanks? We have plenty of science projects that we do. We also have really great companies out there that will help you with different flocculants and coagulants to bind up as many solids as possible, but also break out that free water that now is an effluent, still has to be tested and treated and made sure it's safe to release, but we can get there. Our big X factor is not our drilling fluids. You should be running NSF standard drilling fluids. It's the metals and the other X factor pollutants that are in the ground that we're incorporating, making into that slurry. So those are the things that I want you to think about. We should all have this in our bid. 20 years ago, when I started in this industry on the manufacturer side, we all said in 5-7 years it was going to happen. And we do see it in the Western United States more. But I also want you to think of a disposal plan from this aspect, with all the water that's going on, with scarcity and whatnot. The Colorado River's right behind me. This week I'm going to be out in Denver and Grand Junction. And so I'm here. You sent the text. We're answering the question right now. We need to use the least amount of water possible to create our well, to create our bore field. We need to be environmentally responsible stewards, using a good solids program for control and disposal, and just how we're putting that drilling program together. Because let's face it, the more fluids you use, the larger that borehole becomes. The poor fluid properties of the poor drilling practices, the more grout, the more cement, the more gravel pack, the more X factors that we've done. We need to get into an idea of the least amount of impact as possible. And absolutely, we should be bidding every project with going, hey, we're a co-generator for you. This is your property. Is this something that we're going to see on a 3,200 gallon water well in a residential area? No, most of the time we dig the trench, we got the solids, things start to dry up, everything goes into the trench, we do a good job. But I want you to start thinking 5, 10,000, 100,000 gallons. Those are the things you need to think about. Great question.